The German defenders on Omaha Beach were trained to listen for a single metallic ping, the sound of an American soldier running out of luck. But by the time they popped their heads up to fire, 8 more rounds were already screaming toward their position. This gas-operated monster didn't just win the war, it shattered the 50-year reign of the bolt-action rifle and turned the individual soldier into a high-volume weapon system. But the M1 Garand was a weapon that almost never existed. Behind the rugged wooden stock lay a secret engineering compromise that nearly caused the entire project to be scrapped by the Pentagon before a single shot was fired. Before Patton called it the greatest battle implement ever devised, the Pentagon tried to kill it. They were terrified of the very technology that would save the Western world. This is the story of a machinist who bypassed the military establishment to build a miracle, only to see it modified by a general's ego. By 1932, the United States military was effectively stuck in a tactical purgatory. While the rest of the world looked toward the future, every major power on Earth was still relying on bolt-action technology born in the Victorian era. The standard infantryman was essentially a slow-moving platform for a slow-moving projectile. To fire his weapon, a soldier had to manually manipulate a bolt, which forced his eyes off the target and destroyed his concentration. In the high-intensity firefights of a modern landscape, this was a death sentence. The War Department knew they needed a semi-automatic solution, but the engineering challenges of developing next-generation World War II rifles were considered insurmountable by the leading minds of the time. The problems were purely physical. Early gas-operated systems were notoriously heavy and prone to catastrophic failure. Recoil from full-powered cartridges like the .30-06 Springfield was so violent that it routinely shattered experimental wooden stocks and warped internal receivers. Reliability in the mud and freezing rain of a combat zone was non-existent. The Americans were searching for a miracle in an era of mechanical limitations, and they were running out of time as the clouds of a second global conflict gathered over Europe. They needed a weapon that could provide a massive volume of fire without sacrificing the range and stopping power of a full-sized rifle round. This required a mind that didn't just understand firearms, but one that understood the raw physics of kinetic energy and high-pressure gas. Enter John Garand. He was not a career military officer or a corporate titan backed by millions in venture capital. He was a Canadian-born machinist with a fixation on mechanical perfection and a relentless work ethic. While his competitors at various private arms companies were trying to adapt old, failing designs to fit new requirements, Garand started from a completely blank slate at the Springfield Armory. He was an outsider who looked at the rifle not as a piece of art, but as a machine that had to survive the most hostile environments on Earth. Most early semi-automatic prototypes used a gas trap system at the muzzle, which was notoriously prone to carbon buildup and fouling. Garand's initial production models actually utilized the gas trap system, which was only later replaced by the more reliable gas port design after the rifle had already entered service. Garand perfected a long-stroke gas piston system located directly under the barrel. As the bullet passed a small port, high-pressure gases were diverted into a cylinder to push a heavy operating rod, cycling the action in a fraction of a second. This was a masterpiece of kinetic energy management that allowed the weapon to stay on target while the internal mechanics did the heavy lifting. To ensure the weapon could handle the brutal conditions of a trench, a swamp, or a desert, Garand simplified the internal components. He made them rugged enough to be field-stripped and serviced by a teenager in a muddy foxhole under enemy fire. Every curve of the steel and every cut in the wood was designed for mass production and extreme durability. However, the most controversial engineering breakthrough wasn't the gas system or the rotating bolt. It was the unconventional way the ammunition entered the rifle. Garand rejected the idea of a detachable box magazine, which could be easily lost, bent, or damaged in the field. Instead, he developed a unique internal magazine fed by a steel clip. This decision was rooted in the tactical reality of the 1930s, where military leaders feared that soldiers would lose expensive magazines during a chaotic advance. This engineering choice led to the creation of the en-bloc system, where the entire clip stayed inside the rifle until the final round was spent. This design was not just about feeding rounds, it was about the speed of the reload. By using an 8-round en-bloc clip, the soldier could shove a fresh block of ammunition into the top of the receiver with a single, forceful motion. There was no fumbling with individual cartridges or struggling with a heavy, protruding magazine that could snag on brush or clothing. It was a streamlined, high-speed solution to the problem of sustained fire. But this radical engineering didn't just happen in a vacuum. It was the result of a brutal series of torture tests that saw the rifle buried in sand, soaked in salt water, and fired until the barrels glowed a dull cherry red. The engineering of the M1 was so advanced that it essentially redefined the physics of the infantry squad. For the first time, a single soldier had the firepower of 3 men armed with traditional bolt-action rifles. The Springfield Armory had produced a weapon that was reliable, accurate, and incredibly fast. It was a mechanical symphony of steel and walnut that felt like a natural extension of the soldier's body. Yet, despite its brilliance, the rifle was nearly killed by the very men it was designed to protect. The Pentagon was about to launch a political assault on Garand's masterpiece that threatened to scrap the entire project before a single combat shot was ever fired. The M1 Garand did not just have to survive the mud of the trenches. It had to survive the mahogany boardrooms of the War Department. By the early 1930s, the American military establishment was gripped by a deep-seated institutional paranoia regarding ammunition consumption. High-ranking traditionalists, many of whom had cut their teeth in the static, supply-heavy environment of the Great War, viewed the semi-automatic rifle as a liability. They feared that if you gave an average infantryman the ability to pull the trigger as fast as his finger could move, he would succumb to firepower hysteria. The concern was that soldiers would recklessly deplete their combat loads within the first 5 minutes of an engagement, leaving the entire logistics chain paralyzed under the weight of an impossible resupply demand. This skepticism nearly strangled the Garand in its cradle, as the military elite fought to keep the infantry tethered to the slow, deliberate pace of the bolt-action era. This internal resistance manifested in a fierce technical debate over caliber that almost derailed the entire program. John Garand had originally optimized his rifle for the .276 Pedersen cartridge, a smaller, lighter round that offered several tactical advantages. The .276 allowed for a 10-round capacity, generated significantly less recoil, and was inherently more accurate during rapid strings of fire. It was a forward-thinking design that anticipated the move toward intermediate cartridges seen decades later. For a brief moment, it appeared the U.S. military was on the verge of adopting a truly modern, high-capacity system. The prototypes performed flawlessly, and the engineering community was convinced that the .276 Garand was the future of infantry combat. However, they had not accounted for the uncompromising will of General Douglas MacArthur, who viewed the transition to a new caliber as a logistical catastrophe in the making. MacArthur's intervention was swift and clinical. With the Great Depression squeezing every cent from the federal budget, he pointed to the massive existing stockpiles of .30-06 Springfield ammunition left over from 1918. He argued that it was fiscally irresponsible and strategically dangerous to abandon millions of rounds of high-velocity ammunition for a proprietary new caliber. In a single executive memo, he ordered that the semi-automatic rifle project be restricted to the .30-06 cartridge. This was a devastating blow to the design team. The .30-06 was a massive, powerful round intended for long-range machine gun fire and bolt-action precision. Shoving that much kinetic energy into a gas-operated shoulder rifle required a complete mechanical overhaul. John Garand was forced to return to the drawing board to beef up the receiver, redesign the gas port, and, most significantly, reduce the magazine capacity from 10 rounds to 8. The result of this forced redesign was the birth of the iconic 8-round on-block clip, a component that would become as legendary as the rifle itself. Because the .30-06 rounds were so bulky, they could not be efficiently fed from a 10-round internal magazine without making the rifle's profile unmanageable. The on-block system was the compromise. Unlike the stripper clips used by the German Kar 98K, which were used to top off an internal magazine and then discarded, the Garand's clip stayed inside the weapon and was under constant spring tension. It was a masterpiece of industrial efficiency, allowing a soldier to slam a fresh block of 8 rounds into the action in less than 2 seconds. This engineering pivot turned a potential failure into a tactical advantage, providing a loading speed that no other military in the world could match. While the Pentagon bean counters were worried about cost, the Springfield Armory was busy launching a massive industrial mobilization. The transition to the M1 Garand represented the first time a major military power attempted to mass-produce a semi-automatic rifle as the primary service arm for every single soldier. This was a monumental manufacturing challenge that required unprecedented precision in steel forging and wood machining. The competition was fierce, with rival designers like Melvin Johnson attempting to pitch their own rifles to the Marine Corps, claiming the Garand was too complex for the average rifleman. The rifle wars of the late 30s were a blur of political lobbying, rigged trials, and backroom deals. But the Garand's rugged reliability eventually silenced the critics. It wasn't just a weapon. It was the first true product of the American military-industrial complex, optimized for a war of attrition. By the time the first production models reached the hands of the infantry, the Garand had been transformed from a machinist's passion project into a standardized tool of American foreign policy. The corporate and political battles had forged a weapon that was over-engineered for strength, chambered in a devastatingly powerful caliber, and capable of a sustained rate of fire that shocked foreign observers. The U.S. military had successfully navigated the transition from the 19th century bolt-action mindset to the modern era of rapid-fire dominance. They had bet the lives of millions of young men on John Garand's gas-operated system, and as the first shipments arrived at overseas depots, The world was about to see exactly what happens when an entire army is equipped with the greatest battle implement ever devised. The stage was set for the ultimate test of man and machine in the most brutal environments on Earth. As the M1 Garand began to appear in the hands of frontline troops, the tactical manual for the American squad was being rewritten in real time. This wasn't just a change in hardware. It was a fundamental shift in how ground was taken and held. The heavy .30-06 round gave the individual soldier the ability to punch through cover that would stop smaller rounds, while the semi-automatic action allowed him to suppress the enemy without ever taking his eyes off the sights. The rifle had survived the halls of Washington, and now it was time to see if it could survive the humid jungles and frozen ridges where the firepower gap would be measured not in statistics, but in survival. The Americans were bringing a high-velocity, semi-automatic solution to a bolt-action fight, and the results would be nothing short of a tactical revolution. The true test of the M1 Garand began in the Pacific Theater, where the dense canopy of Guadalcanal turned every patrol into a claustrophobic death trap. Japanese defenders relied on the Arisaka Type 99, a sturdy bolt-action rifle that was effective but slow. In the chaotic green hell of the jungle, engagement distances were often less than 20 yards. When an ambush was sprung, the side that could put the most metal in the air within the first 3 seconds usually walked away. American Marines found that the M1 Garand allowed them to break an ambush with a wall of sound and lead. While the Japanese soldier was cycling his bolt after a single shot, the Marine was already on his 4th or 5th round, effectively pinning the enemy down before they could reposition. This volume of fire compensated for the lack of visibility, allowing squads to suppress muzzle flashes they couldn't even clearly see. As the war moved into the European theater, the M1 Garand faced a different kind of adversary in the German Kar 98K. On the open fields of France and the urban ruins of Italy, the German doctrine centered on the MG-34 and MG-42 machine guns, with riflemen serving as ammunition carriers and flank protection. The M1 Garand disrupted this entire tactical ecosystem because every American rifleman possessed semi-automatic firepower. The squad was no longer dependent on a single crew-served weapon to provide suppression. If the American light machine gun jammed, or the gunner was neutralized, the rest of the squad could pick up the slack. They maintained a base of fire that kept German heads down, allowing maneuver elements to close the distance. The M1 Garand effectively turned every individual soldier into a mobile, precision machine gunner, a capability the Wehrmacht simply could not match with their standard-issue infantry kits. The sheer velocity and kinetic energy of the .30-06 Springfield round proved decisive in the hedgerows of Normandy. German soldiers often sought cover behind thick earthen banks or stone walls, believing they were safe from small arms fire. They quickly learned that the M1 Garand possessed terrifying penetration power. The heavy 9.7-gram projectile could punch through several inches of wood or masonry and still retain enough energy to neutralize a target on the other side. This forced the enemy to retreat further back, surrendering tactical advantages they had held for years. The psychological impact of being under constant, rapid fire from a full-powered rifle cannot be overstated. It created a sense of overwhelming technical superiority that boosted American morale while eroding the confidence of the Axis powers, who were still trapped in the slow, rhythmic cadence of the 19th century bolt-action era. In the hands of specialized units like the Rangers and the 101st Airborne, the M1 Garand became an instrument of surgical aggression. During the defense of Bastogne, paratroopers used the rifle's rapid-fire capability to hold off much larger German formations. The ability to quickly transition between targets without losing a sight picture meant that a single paratrooper in a well-placed foxhole could simulate the presence of a much larger force. This tactical illusion was critical in holding the line against the final German offensive. The rifle's reliability in the freezing mud of the Ardennes served as the ultimate validation of John Garand's engineering. While other experimental weapons seized up in the cold, the M1's heavy operating rod and robust gas system continued to cycle. It was here that the weapon earned its reputation as the most dependable tool in the Allied arsenal, proving that high-tech semi-automatic fire and rugged durability were not mutually exclusive. The transition from the slow, deliberate shooting of the Great War to the aggressive, high-cadence fire of World War II was solidified by this single platform. It changed the very nature of infantry training, shifting the focus from slow-fire marksmanship to rapid-fire engagement and rapid reloading under stress. By the time the war reached its conclusion, the M1 Garand had fired billions of rounds across multiple continents, proving its worth in the most extreme environments on Earth. It had outshot the bolt actions of the past and held its own against the emerging class of submachine guns by offering superior range and stopping power. However, as the smoke cleared from the battlefields of Europe and the Pacific, a deeper look into the weapon's mechanics revealed that the very features that gave it such a massive advantage also carried a hidden technical price that nearly derailed its legacy before the next conflict began. The reality of the M1 Garand was not always as polished as the propaganda suggested during the high-stakes mobilization of the early 1940s. While the world marveled at its semi-automatic speed, the soldiers in the mud were discovering that the rifle was a jealous mistress that demanded absolute precision during every reload. The most notorious of these mechanical pitfalls was the legendary injury known as Garand thumb, a hazard that became a rite of passage for millions of recruits. Because the bolt was held back by a catch against a powerful spring under immense tension, the act of pressing a fresh 8-round in-block clip into the internal magazine created a hair-trigger situation. If the shooter did not use the side of their hand to brace the operating rod handle while pushing down with their thumb, the heavy steel bolt would slam forward like a guillotine. It was a brutal, bone-crushing design flaw that could sideline a soldier before he even reached the front lines, highlighting the inherent danger of a weapon that prioritized raw mechanical speed over ergonomic safety. Beyond the physical risks to the operator, the M1 Garand carried a strategic vulnerability that kept analysts and psychologists awake at night. This was the infamous metallic ping, a distinct, high-pitched ring produced when the steel clip was automatically ejected after the final round was fired. In the quiet, tense moments of a close-quarters skirmish, this sound acted as a biological clock for the enemy, signaling exactly when an American soldier was empty and vulnerable. While historical debates continue regarding how often German or Japanese troops actually exploited this sound in the roar of a full-scale firefight, the psychological impact on the American infantrymen was undeniable. Soldiers were known to carry empty clips to throw against rocks, attempting to trick their adversaries into thinking they were reloading, a desperate tactical improvisation born from a perceived mechanical weakness that John Garand had never intended to become a signature of the weapon. The technical compromises forced upon the rifle by Chief of Staff General Douglas MacArthur's insistence on the .30-06 Springfield cartridge created a series of cascading engineering headaches. Originally, John Garand had optimized his masterpiece for the lighter, more modern .276 Pedersen round, which would have allowed for a 10-round capacity and significantly less recoil. When the Pentagon mandated a return to the heavier caliber to exhaust existing ammunition stockpiles, the internal geometry of the rifle had to be stretched to its absolute limit. This forced the adoption of the 8-round clip, a capacity that many frontline officers felt was too low for a high-intensity modern war. This pivot also increased the internal pressures of the gas system, leading to cracked operating rods and timing issues that required constant maintenance in the field. The M1 Garand was essentially a high-performance engine being forced to run on a fuel it wasn't originally designed for, leading to a complex relationship between the soldier and his gear. These mechanical quirks and political interferences almost caused the entire M1 program to be scrapped or replaced by more conventional designs during the early stages of the war. Critics in Washington pointed to the ammo wastage problem and the complexity of the gas-operated system as reasons to revert to reliable bolt-action technology. It was only through the sheer success of the weapon in the hands of the first waves of paratroopers and Marines that these concerns were finally silenced. The M1 Garand was a weapon of contradictions. It was the most advanced infantry tool of its time, yet it was plagued by a reload process that could break your hand and a sound that could give away your position. Despite these fatal compromises, the American soldier learned to master the machine, turning its flaws into a unique combat language that would define the infantry experience for a generation. The legacy of the M1 Garand did not end when the last transport ships returned from the Pacific or when the Korean armistice was signed. It left a permanent mark on the very concept of national sovereignty and the industrial requirements of modern warfare. By the time production ceased, over 5 million units had been stamped out by the Springfield Armory, Winchester, and even unlikely manufacturers like International Harvester. This massive industrial mobilization proved that a high-precision, gas-operated semi-automatic rifle could be manufactured at a scale previously reserved for simple bolt-action repeaters. It transformed the American infantryman from a rifleman into a mobile fire support platform, setting a standard that every other superpower spent the next 3 decades trying to match. The engineering DNA of John Garand's masterpiece eventually branched out into the most iconic weapons of the Cold War. When the U.S. military sought a successor, they didn't look for a radical new invention. They looked to refine the Garand. The resulting M14 was essentially an evolved M1, featuring a detachable 20-round magazine and a shortened gas system. Even the legendary AK-47 owes a silent debt to the Springfield Armory. While the aesthetics differ, the long-stroke gas piston principle and the concept of a reliable semi-automatic action are echoed in the most prolific assault rifles on the planet. To understand how the M1 Garand works is to understand the fundamental physics that govern almost every modern infantry weapon currently in service. Beyond the springs and steel, the Garand remains a cultural titan, synonymous with the grit of the greatest generation. It was the tool that validated General George S. Patton's bold claim, proving that superior technology, when paired with aggressive small unit tactics, could collapse empires. The rifle bridged the gap between the slow, deliberate warfare of the 19th century and the high-intensity, rapid suppression reality of the modern age. It was a weapon born of compromise, forced into a specific caliber by political heavyweights, and plagued by a reload quirk that became the stuff of legend. Yet, it never faltered when the stakes were the survival of the free world, cementing its place as the most influential U.S. military firearm in history. Today, the M1 Garand is more than a museum piece. It is a reminder of a time when engineering was measured in wood and heavy iron. It stands as a monument to the moment the individual soldier was given the power to control the tempo of a battle through sheer volume of fire. The ping of the 8-round N-block clip is no longer a tactical anxiety, but a celebrated echo of a vanished era. It represents the end of the bolt-action era and the violent beginning of the semi-automatic world we now inhabit. The Garand didn't just win a war. It defined the physics of the modern squad and changed the way we view the relationship between a man and his rifle. If you appreciate this deep dive into the engineering and history that forged the modern battlefield, make sure to subscribe to the channel. We are exploring the most influential tools of conflict, from the trenches of the past to the high-tech systems of tomorrow. In our next investigation, we will look at the weapon that rose from the ashes of the Eastern Front to challenge the Garand's legacy on a global scale. The history of warfare is written in lead and steel, and the story of the M1 Garand is perhaps the most significant chapter ever recorded. It remains, as it was in 1944, the greatest battle implement ever devised. The mechanical soul of the M1 Garand lives on through the civilian marksmanship program, where these rifles are still issued to a new generation of shooters who seek to understand the weight of history. Holding one today, you realize it is not a light weapon. It is a 9.5-pound anchor of walnut and forged steel that demands respect and physical strength. This weight was a deliberate choice, intended to soak up the punishing recoil of the .30-06 Springfield round, allowing a soldier to stay on target for all 8 shots. It is this tactile connection to the past that keeps the Garand at the forefront of U.S. military firearms history. Every time a collector pulls the trigger, they are experiencing the exact kinetic feedback that a paratrooper felt over the drop zones of Normandy. When comparing the M1 Garand versus Kar 98K, the debate often centers on accuracy versus speed. But the true victor was decided by the evolution of the squad. The Garand proved that a semi-automatic rifle allowed a team to suppress an enemy effectively enough to move, flank, and terminate a threat with surgical precision. This shifted the entire philosophy of the American War Department toward a focus on firepower density. We see this legacy in every modern engagement, from the mountains of Afghanistan to the urban corridors of current conflict zones. The high-capacity magazines and rapid-fire capabilities of the M4 and M16 are the direct descendants of the tactical revolution started by John Garand in a quiet corner of the Springfield Armory. As we look back at the millions of units produced and the countless lives they protected, the M1 Garand stands as a testament to the power of American industrial might. It was a weapon that arrived at the perfect moment, bridging the gap between old-world craftsmanship and new-world mass production. It was flawed, it was heavy, and it was demanding. But it was exactly what the world needed to break the stalemate of the bolt-action era. The story of the Garand is a story of human ingenuity, overcoming political interference, and engineering hurdles to create something truly immortal. It is a piece of living history that continues to speak to us through every metallic ping that echoes across a firing range. If you want to see more tactical breakdowns of the weapons that redefined human history, hit the notification bell and join our community of historians and ballistics experts. We are committed to bringing you the unfiltered truth behind the world's most iconic firearms. Our journey through the Weapon Chronicles is just beginning, and the next chapter will take us into the heart of the Cold War to examine a rifle that became a symbol of revolution across the globe. The M1 Garand set the stage, but the arms race it ignited would change the world forever. Stay tuned, because the evolution of firepower never stops.